All right, so the bottom line is what we've realized is that just knowing the molecular formula isn't enough to tell us about the chemistry and the behavior of molecules. We need to have the Lewis structure. From the Lewis structure, we need to be able to determine the three-dimensional structure. This is that wedge dash business I was telling you about. This is all tetrahedral. We also sometimes, when we see this, we actually envision the shape filling model. And this is an even more sophisticated model showing the electron density, regions where you have higher electron density in this molecule. The electrons are kind of moving all over throughout the whole molecule. So we have different models to represent the same thing, in this case methane, in this case ammonia. Here's all the different models we use for ammonia, and here's all the different models that may be used for water. And in each case, we have a reason for describing the molecule in that way, depending on the information that we need to get. Do we need to understand the bond angles? Do we need to understand what we're going to be looking at next semester? We'll be visiting these shapes again and recognizing something about whether or not the molecules are symmetric or not. That's going to tell us about the behavior of the molecules. So there's reasons why we need to have more sophisticated models. And so now that we have this concept of three-dimensional shape, we can provide more sophisticated models, and we can dig deeper and try to understand better why these molecules behave differently. Here's just two more: carbon dioxide, and then here's ozone. Carbon dioxide is linear, and ozone was bent. And because of the non-bonding, there's only 3 regions of high electron density here. It's bent. The electronic shape is, in this case, would be what? There's 1, 2, 3 regions of high electron density. One here, one here, one here. Can you say what that would be? That would be trigonal planar, and the bond angle is not 120, it's 117, and you should be able to say why. So you should be able to figure all this stuff out yourself for ozone. You should know that it's bent. You should know about why the bond angle is a little bit less than 120. Here's a space filling model. All the atoms are the same, but they're not linear. They're bent. And then here's the electron distribution model. Okay, so what we've done for ourselves here is we've gotten a more sophisticated look at compounds.